안녕하세요. 로얄아이비에서 IB 수학 AI HL을 담당하고 있는 제임스입니다. 이번 영상에서는 간단하게 2024년 페이퍼 1 그리고 페이퍼 2에 출시된 문제 한 개씩 풀이 과정을 다뤄보도록 하겠습니다. Okay, this question is from the IB Math AI HL 2024 May Paper 1 Time Zone 1. Okay, when studying big cats, researchers use a model in which the mass m kilograms of an animal is directly proportional to the cube of its shoulder height. A cheetah has a mass of 64 kilograms and shoulder height of 0.8 meters. And part A says, use the model to find an expression for m in terms of h. Okay, so let's go ahead and do this first part here. So we know that, so researchers use a model in which the mass of an animal is directly proportional to the cube of its shoulder height. And so in order to express this correctly, we change it to an equal sign and introduce a proportionality constant k times h cubed. So this is the expression. And we have to use the information given from the problem to find k. Okay, so here we know that the mass of the cheetah is 64 kilograms, right? And the height of the cheetah is 0.8 meters. And so we can just substitute these values into the equation to find k. And so we have 64 equals k times 0.8 cubed. And if we rearrange for k, actually if we calculate 0.8 cubed, it's 0.512. And then rearrange for k, we get 64 over 0.512. That should equal 125. Okay, so our expression would be m equals 125 h cubed. Okay, the second part, hence find the mass of a different cheetah with a shoulder height of 0.75 meters. And so now that we have our expression, we just have to substitute our h into this formula. So h is 0.75 meters. And so our mass would be 125 times 0.75 cubed. And that should give us about 52.7 kilograms. So this one's pretty straightforward. Okay, part B. Rubner's law states that the energy needs of an animal E are directly proportional to the square of H. So I should go ahead and immediately write that down. E is directly proportional to the square of H. And so if I change this to an equal sign, I introduce a proportionality constant. And I'm going to call it, say, N. NH squared. Okay? The energy needs of a lion of mass 220 kilograms are k times the energy needs of a cheetah of mass 64 kilograms. Find the value of k. And so we can set this up by creating a ratio. So the energy needs of a lion, I'm going to label it E sub L. And that divided by the energy needs of a cheetah, E sub C, and that is k, right? Because this is from this, E sub L equals k times E sub C, right? And so we just have to find an expression for the energy needs of a lion and the energy needs of a cheetah. And so we could find the energy needs of a lion as n times the height of the lion squared, right? And so let's go ahead and find the height of a lion. So the mass of the lion is excuse me, the mass of a lion is 220 kilograms. And so we found from part A that m equals 125 h cubed, so we can use that information to find the height of the lion. And so ml equals 125 hl cubed. 220 equals 125 hl cubed. And so HL should come out to about, I'll just go ahead and leave it as that. Okay. And then we know that the height of the cheetah is 0.8 meters. And so actually, let's go ahead and finish up writing the expression for the energy needs of a lion. So that's n times the cube root of 1.76 squared. Okay. And then the energy needs of a cheetah is n times 0.8 squared. And so now we can find K by doing EL over EC, which is n times the square of the cube root of 1.76. But then these n's get canceled, and so we don't even have to find those values. And then if we calculate this, should come out to 2.28. So that's our value of K. And so I want to go over how your answers are graded. Notice that this part A is worth 4 points. Now, the points are given in very specific manner. And so there's a thing called the method points and the answered points. So for this part 1 of A, it's worth 3 points, and this part 2 is worth 1 point. Now, the points are given at these very specific steps. The fact that you show this will get you 1 method point, okay? And if you calculate everything correctly and lead to over here, this will get you an answer point. Okay, so this is the method point, and then this is the answer point. And then calculating everything correctly leading up to here will give you another point for the correct answer. Okay. And then for part 2, the answer is given for just simply substituting everything in. And of course, calculating everything correctly. Okay. For part B, the points are given at h equals, so there's a point given over here for finding the height of the lion correctly. And then setting this part up, these equations up, the fact that you can create an equation that models the situation correctly, this is worth 1 point. And then finding the expression for K, this part is worth 1 point. And then the final answer is worth 1 point. Okay, so again, setting it up correctly, calculating the height of the lion, and then finding an expression for K, calculating it correctly, leading to the final answer. And these are all worth a total of 4 points. Okay, so this question is from paper 2 of 2024 May, time zone 1. The interior of a vase is modeled by rotating the region bounded by the curve y equals 1/2 x squared minus 1, and the lines x equals 0, y equals 0, and y equals 15 through 2 pi radians about the y-axis. So it's a full revolution around the y-axis. The values of x and y are measured in centimeters. The vase is filled with water to a height of h centimeters. Find an explicit expression for the volume of water in terms of h. Okay, so here we just have to use the formula for the volume of revolution, okay? And that is in the formula booklet. The formula goes like this. So volume you can find by having pi y1, y2 as the lower and upper limits of integration times ry squared dy. Now, how this formula works is if you have the x and y axis like this, and you have some function, I'll go ahead and draw this function, okay? Because this is pretty straightforward. It's a quadratic function, so it's going to be a parabola. It's a positive 1/2, so it means it opens up, and it's shifted down 1 unit. So here will be -1, and it should open up like that. Let me draw it again. Something like that. okay? And it's bounded by the lines x equals 0. So it should be x equals 0. Oh, wait. Say x equals 0. Y equals 0. So this is x equals 0. X equals 0, y equals 0, and y equals 15. So I'll say maybe it's somewhere over here. Okay, so y equals 15. And so if this region's rotated, revolved around the y-axis, it's going to create a 3D shape, and we're trying to find the volume of the vase. Okay, so the vase should look something like that. 3D, and then we're trying to find the volume of this shape. Okay, and so how this formula works is this dy is an infinitesimally thin rectangle going this way. Okay, and this is dy. So if we go from here to here, this thickness is dy, and this r of y is the radius from the y-axis extending to the function itself. That's the radius, right? So the radius from this point to here is going to be the function value at y equals some value. And then the radius from here to here is going to be the function value at y equals some value. Okay? But the thing is, this function is rotated about the y-axis, and so we have to rearrange the function y equals 1/2 x squared minus 1 in terms of x. Sorry, in terms of y. So we have to make this so that it looks like x equals. Okay? So let's go ahead and do that first. So we have y. So we have y equals 1/2 x squared minus 1, and we want to rearrange this so that it's x equals. So let's go ahead and do this one by one. X squared equals 2 times y plus 1. X equals square root of 2 times y plus 1. So what I did was I brought this -1 over to the left. It becomes y plus 1. Multiply everything by 2. It becomes 2 times y plus 1, and x squared is left alone. And then I square root the whole thing. Okay, so this is our function. This is our function that we want to integrate. It's this part over here, this function, in terms of y. Okay, and so our volume, in terms of h, is going to look like this. Pi, because it goes from height of 0 to a total height of h, those are our limits of integration. And then we have square root of 2 times y plus 1 squared dy. Okay? And so we can just simplify to make it look like this, because the square root goes away. And then we have, so we can take out this 2 as well. So that should look like 2 pi 0 to h of y plus 1 dy. And then the integral of y plus 1 is just going to be y squared over 2 plus y. And we're evaluating this from 0 to h. And so that should look like 2 pi h squared over 2 plus h minus 0 squared over 2 plus 0, right? So we substitute this h into the y values, subtract the value that we get when we substitute zeros in there. So h minus 0. Okay? And then we should get 2 pi times h squared over 2 plus h. And if we simplify that, it should look like that. Okay? And so that is our answer for part A. Okay, the vase is filled at a rate of 20 cubic centimeters per second. Find the time taken to completely fill the vase. So as soon as we see this rate problem to a problem like this that involves calculus, we can kind of anticipate that it's going to be a related rates problem. Okay, so let's go ahead and do part B. Well, first we have to find the total volume first, right? And so you can see that the y is 15. So it goes from y equals 0 to y equals 15. So our height is 15 centimeters, right? So we should find the total volume first, because the time taken is the total volume divided by the rate of filling, right? How long does it take to fill a given total volume? So we can find the total volume by putting in 15, because it goes from y equals 0 to y equals 15. So that should just give us pi times 15 squared plus 2 times 15. And calculate everything, we should get 255 pi cubic centimeters. Okay? And so our t is just this divided by 20. And that should give us about 40.1 seconds. Okay? Now part C, find the rate at which the height is changing when h equals 10 centimeters. So this is a classical related rates problem, right? And so let's go ahead and set up the related rates formula. And that is dv over dt equals dv over dh times dh over dt. So this is a standard procedure for setting up a related rates problem, right? This comes from the chain rule. And so we're trying to find dh dt. And so we should rearrange everything. So we're trying to find this guy. dh over dt equals dv over dt all over dv over dh. Okay, so we know that we're trying to look for dh dt because the problem asks us to. It tells us, right? And so the height is 10 centimeters. And so we know dv dh. So the dv dh we have already found in part A. We haven't actually found it, so we can just differentiate what we found in part A with respect to h and then find dv dh. And so that is just pi times 2h plus 2, right? Because our volume was pi times h squared plus 2h. And if we differentiate this with respect to h, this is what we get. And then we can plug in h equals 10. So at h equals 10, dv over dh becomes pi times 2 times 10 plus 2, that equals 22 pi. Okay? And the dv dt they give us, dv over dt, they already told us it's 20 cubic centimeters per second. So now we have everything we need, right? dh over dt equals dv dt over dv dh. And that should give us 10 over 11 pi centimeters per second. And so you can leave your answer like this, or you could just go ahead and calculate it with your calculator and get 0.289 centimeters per second. Okay. Now in terms of the points distribution, for part A, you're given a point for simply writing this down. That's 1 point. And then showing that if you rearrange for x, then we get this process. If you do this correctly, then you get 1 point. And then setting the integral up correctly is 1 point. And then leading to the final expression, of course, is going to be 1 point. Another one's given going from here to here is worth 1 point. So a total of 5. And then for part B, you're given 1 point for finding the volume of the base. That's 1 point. And then the time to fill the vase, calculating like that, should get you 1 point. And then for part C, you're given 1 point for writing this formula down, another point for creating expression for dh dt, and then another point for differentiating differentiating v with respect to h. And then you're going to get 2 points for, you're going to get 1 point for substituting in h equals 10. And then you're going to get 1 point for correctly expressing everything with numerical values, and then you get 2 points for the final answer. So a total of 7 points. Okay. Now, depending on your work, the points might be distributed a little bit differently, but some steps are possible only if you know how to do the previous process. But so if you don't show the previous process, and for example, and you just come here without, I don't know, explicitly stating this, then they assume a method point, because the only way to get the correct answer is to calculate this value with the numerical values substituted in. Okay, so you don't have to show every single step, but this is the overall flow of point distribution. Okay, so that's it for the 2024 past paper question solution overview. If you have any questions or if you want to have more classes with me, please let royalib know. 네, 그 2024년 기출문제풀이는 여기까지고요. 로얄아이비의 제임스였습니다. 혹시 더 궁금한 점 있으시거나 수업에 대한 문의는 로얄아이비로 문의 부탁드립니다. 감사합니다.